Okay, so describe a function, g of x, in terms of f of x. If the graph of g is obtained by vertically stretching f by a factor of 3, then shifting the graph of f to the right 5 units and upward 3. Okay. So, yeah, it's kind of funny the way they wrote it out. Let me grab this right here. Let's just bring it down. Well, let's just ignore their lingo for a minute. How about? And let's just do what they're saying. So basically, let's go step by step. So they're taking some function f of x. So you start with f of x. Okay. It says in terms of f of x. So you're starting with f of x. And then what do you do first? So first, if the graph of g is obtained by vertically stretching f by a factor of 3. Okay. So vertically stretch by a factor of 3. Vertically stretched by a factor of 3. What that's going to do is that's going to go 3 times f of x. Multiply by 3 in the front. So it's a y effect not in x's world. Everybody see that? So it's a stretch. It's not a movement so far. There's going to be some movements coming in just a second. But this is a stretch, not a movement, right? We stretched the thing vertically. So you know vertically means y. Has to be y, has to be up, down, right? They vertically stretched it up. And it's a multiply, not an adding, subtracting. Why not? Adding, subtracting moves graphs, whereas multiplying stretches them. So it's multiplying by 3. If you multiply by -3, it'll stretch it and flip it. But they didn't say flip it. So is that making sense? So if you multiply by a negative number, then it flips it along with the stretch. If you just multiply by -1, it just flips it, no stretch, because 1 doesn't change anything, right? But if you multiply by -3, then it would both stretch it and flip it. We're just multiplying by +3, so it's just a stretch. But it's a multiply. It's not adding. Adding moves, multiplying stretches. It's a y. It's not like this. It's not 3 times x. That would have a sideways stretch effect. That's not what we're talking about. It's a vertical stretch. So it's got to be in the front, not in x's world. So it's not this one. It's not in x's world. Okay. Next, step 1. Step 2. We're going to go right. We're going to move it. So not stretch it this time, but now move right 5. What's going to move this graph right 5? Well, you know, we're going to take what we had before. 3 times f of x. And then how do we move right 5? Well, we got to come into x's little world. We got to go x minus 5. Remember, it's opposite. X is always opposite. So -5 is actually right 5. They said left 5, I would go +5. X is always opposite. And we got to be in x's world, in the parentheses for right, left, in x's world, because it's a right, left. It's an x effect. Okay, last step, step 3. Now they say right 5 and 3 up. So move up 3. So what is going to move this graph? We've got 3 times f of x minus 5. And then we've got to move it up 3. There we go. Just add 3 at the end, huh? Up 3, not in X's world, Y's world. Right? Because it's not in the parentheses. It's not in X's world. It's in Y's world. So it's up 3. So there we go. So basically, how do we answer this question? Well, as you see, now we'll get to their lingo. See what their lingo is? They're basically saying your function, see right here, I'll just grab this right here. Your function is, here, I'll bring down. Your function is a f of x plus b plus c. So they're asking you, okay, what's the a, b, and c? Well, 3 is the a. Let me back that up, do it with a different color, make it more clear. 3 is the a. Minus 5 is the b. You must, yeah, but it's adding. Well, it's adding a negative 5. That's the same thing as subtracting 5. Right? You with me? Adding negative 5 is exactly the same as subtracting 5. And then this plus 3, that's c. So a and c are 3. B is negative 5. This is our function. This is what we've done to our function. So you just come up here and you go, oh, a is 3, b is minus 5, c is 3, to make all those changes happen in that function, just like that.